Set up here for the experiment to check the relationship between current and voltage for a diode. So remember, a diode is a component that allows current to flow one direction only. And as we've just said, okay, we need the diode to be in forward bias. So for the diode to be in forward bias, the negative has to be connected to the negative. Now the negative of the diode is shown with the little silver band. Okay, and I have it color coded so that in black we're going back to the minus. Okay, so that is connected to the negative. The positive is in red. Okay, and that is connected to the other end, as you can see. Okay, we have our voltmeter across the diode as before, and we have the voltmeter in this case where we need to voltmeter that measures between 0 and 1 volt. So I've changed the digital voltmeter. We're continuing to use the milliammeter for this. Okay, when you're doing this in school, be very careful because the current will get very large, and if the current goes above 200 milliamps, you will blow the fuse in the multimeter, and I will be very sad. Okay, because it takes a lot of effort to replace them. Okay, so that won't happen. Right. Okay, so here we go. So now in this case it's a bit odd because as we'll see as we move up along. Okay, if we go up to 0.1, no current. 0.2, 0. So for 0.1 and 0.2, you're putting in 0 milliamps. 0.3, 0 milliamps. 0.4, 0 milliamps. You're beginning to wonder is it working at all. 0.5, and we have 0.1 of a milliamp. So we put in 0.1 of a milliamp. Okay, we move up to 0.6, and we're up to 1.5 milliamps. So now we move up to 0.7. Okay, try to get it spot on 0.7. There we go, 18 milliamps. Okay, we're going to go up to 0.8. And we're trying to avoid blowing this thing up. So we're just going to get away with 0.8. There you go. So take your reading for that. Okay, and you now draw your graph. It is pretty clearly not going to be a straight line graph through the origin, and we move on from there. Okay.